Hello, this is our ECE528 project, the recyclable classifier. I'm Christopher Alquist.
And I'm Ryan Gleckler. So why is the recyclable classifier important? So the EPA put out a study in 2018 that showed that the USA alone produced 69 million tons of recyclables alone. And sorting recyclables is still a very human interaction-based task, and it's unsanitary. You can see in the image on the right that they're sorting the image on a conveyor belt, and we figured that this task could be automated using computer vision, which could provide faster sorting and eliminate the ecological impact of waste.
So one of the technical challenges that we needed to that we faced during this project is that computer vision relies heavily on machine learning, and so machine learning is very resource hungry and relies upon a good data set in order to really abstract the features necessary to classify image properly. So on an embedded platform, we do not have very many resources. Very resource restricted. I gave an example of the Raspberry Pi on the right here. And as you can see, it's not very big and that it doesn't have a lot of resources, and so machine learning is a challenge on it.
So our approach utilized a Raspberry Pi Model B 8 GB. We did not utilize hardware acceleration in our implementation, which turned out to be a big struggle that we were battling with when we attempted to. We were averaging 4 to 5 frames per second on our live video, and our inference took about 1.2 seconds on average. We did it with transfer learning built on the ResNet 50 model, which ended up being our best option, and we used a drinking waste classification dataset from Kaggle, which can be seen on the right in that grid. In training, we used an 80-20 train test split and achieved a validation accuracy of 98.81%.
Right now we're going to show a video demonstration. This video is sped up 1.75 times as fast just for the sake of this video. So we showed our setup here, and now we just put objects in front of it. As you can see right now, it's really good at predicting cans. We about have 3 objects per class here, and we're just going to show 3 positions, horizontal, vertical, and a perpendicular to the camera.
Yeah, so we can see that it's fairly certain with each can, always about 99% accurate. With the crushed can, especially on its side, it was less certain, and I think this is because of a bottle can confusion.
Mm-hmm. Plastics here, it's really certain about, and we're about to see right there, usually with bottles, plastic bottles, it thinks that when they're facing vertical, sometimes it'll classify them as cans. That's not an example there where the previous one was. And that's just one of the areas of which this classifier gets confused.
Yeah, and we think this is due to it extracting a feature of a circle, which is often seen on the can or where the tab is on the can.
So we have our glass data set here, and as you can see, it's very certain that this is a glass. That's a kind of an oblong shaped glass, so we were very pleased, and that's the can confusion that we've been talking about. And now with bottles, these kinds of glass bottles, it's very certain of what it's seeing. Even on its when it's vertical, it's very still certain it's a glass. We see that with more less transparent glasses with different colors, it works better for these ones.
Yeah, and we think it's so certain of glass because our data set had a lot of very good glass images in it.
And in this one, we used 3 objects of each class that were not the typical ones. Like this one is a can of Vienna sausages that wasn't like a soda can. It was very certain that it was a can. And this is a crumpled piece of plastic, and it's very still certain that it's a plastic here, showing that it abstracted features beyond its geometry of being bottles and cans and such, but actually abstracted features that were intrinsic to its material, showing promising features for the future.
So in this related work, we looked at another implementation of this kind of technology that another group performed. They based their model on Inception v1, which is Google's model, and achieved an accuracy of 94%. And we saw that they also took 4.2 seconds per classification, which is significantly slower and less accurate than what we've implemented here. And their trash sorting was done automatically through the use of interfacing with the Arduino Uno and a stepper motor setup.
So what does this mean? This application is very important, as we demonstrated, with sorting trash and trying to lessen the ecological impact that garbage has today. We show that we have a proof of concept for this application through the previous related work and how well we are able to classify generally different recyclables. This current implementation is slow, and it can only do one object at a time because it's an object classifier. And this could be solved in the future work with hardware acceleration and using object detection so we can detect more than one object at a time, and really if it would be able to pick apart different parts of like a clump of garbage rather than having each individual article be placed neatly in front of it. Thank you very much.
Thank you.